All right, so for the rest of the week, we're going to take a look at complex numbers and how we can write them in what's called trig form. Okay, so today and tomorrow's topics are going to be related, but different from solving triangles. Okay, we're done with solving triangles for this week. All right, so I'll do a little bit of review of some things with complex numbers, and then we'll get into some new stuff. Okay, so remember, this is how you write a complex number. It's a plus bi. When we get into doing some graphing, we'll use x and y as our variables. But a lot of times in textbooks, you see a and b. A is the real part. B is the imaginary part. Okay, and this is called standard form. Standard form. Standard form is perfectly fine to do arithmetic with complex numbers, especially if you're just adding and subtracting. In fact, that's how we prefer to add and subtract, standard form. If you have to multiply, divide, raise to a power, or take a root, okay, we want to use trig form. We're not going to raise to powers and find roots today. Okay, we will practice how we multiply and how we divide. Okay, I'll show you how we multiply and divide in standard form, just a reminder, the old way, and then you'll see how much faster the new way is going to be, okay, in trig form. All right, so first I just want to look at how we can graph a complex number, okay, because a lot of things that we do today, we have to know the quadrant our point is in that we're working with. So I'm going to show you how you graph it. Basically, to graph a complex number, if you had a plus bi, it's just like graphing the point a comma b. So instead of having an x-axis and a y-axis, okay, when you have complex numbers, you have a real axis and an imaginary axis. Your real axis is horizontal. The imaginary is vertical. The directions work just like you would expect them. For the real axis, positive is right, negative is left. Imaginary, positive is up, negative is down. So for our first example, we're just going to look at some different points and graph them. That's it. Does everybody have the diagram of the complex plane? Okay. All right, so let's graph these 4 points. Looking at that first point, what is my real part? Yep, real part, it's just a number, -4. What's the imaginary part? So the imaginary part is just the -2. Yeah, just the number. Okay. The I is just there to tell you what's in front of it is imaginary. Okay. So real part, -4. Imaginary part, -2. Okay, which axis is my real axis again? Horizontal or vertical? Horizontal. It's my real. It's my imaginary. So starting from the origin, how would I graph the point -4 minus 2i? Okay?
4 down 2.
Yep, I'm going to left 4 and then down 2. That's it. That's the point, -4 minus 2i. And now what we're really going to use that for is, now we know we're in quadrant 3, we're going to do something later on. All right, how about -2 plus 3i? How about Corey? How do we graph that?
-2 plus 3.
Mm-hmm.
Just like that. So -2 on the real axis and then up 3.
So -2
To the left.
to the left, yep. And then
Up 3.
up 3. Okay, that's -2 plus 3i. How about 5i? What's the real part there? 0. Okay, so this is like graphing 0 plus 5i. So it's like graphing the point 0, 5, just up 5. Okay, Olivia, what's the real part of 6? 6? What's the imaginary part? 0. So this is like 6 plus 0i. How would we graph 6? Yep, positive 6 on the real axis, which is to the right. These two are special cases. Okay, these are right on the axes. So we're going to talk about how the special cases work versus when we land in a quadrant with what's going to be coming up. Okay, any questions on how to graph a point? All right, next thing we're going to look at is how we find the absolute value of a complex number. What's the absolute value of a real number? What's the definition? Could really say it in like 3 words.
Always positive.
Well, that is a characteristic of it. It's always positive.
Negative.
But how do you find it? Think about it visually. What's absolute value?
Like graphically?
Yeah, graphically.
It's always in the positive. Far away from 0.
Yeah, the distance from 0. That's it. How far away it is from 0. Well, with a complex number, it's the same idea, except we're not finding the distance from 0. We're going to find the distance from, what do you think? Well, what would correspond to 0 in a 2-dimensional system? You should think about on a coordinate plane, because 0 is usually for a number line, right? You got 0 in the middle of your number line, but here we have 2 number lines,
The origin.
which is the origin. Okay, so we're going to find the distance from the origin. Right, and the way we really do it is think of it as a triangle. Here's your point A plus BI. The hypotenuse of this triangle is really what we're looking for. That's the distance from the point to the origin. The triangle that we just made has 2 legs. One leg is A units long. That's the real part. The other leg is B units long. That's the imaginary part. So how would we find the absolute value of a complex number, or the hypotenuse of this triangle? Yeah, we're going to use the Pythagorean Theorem. So it's going to be a squared plus b squared. Add them up. We take the square root. Okay, so the absolute value of a complex number, it's really just the length of the hypotenuse in a triangle. Okay, when we're dealing with absolute value, I think somebody mentioned this earlier, what kind of number do we always get? Positive. Or actually, it could be what as well, besides positive? It could be 0. So we will never get a negative.
Unless you put the negatives in.
What's that?
Unless the negatives in front of absolute signs.
Oh, you mean if they added extra symbols in front?
Yeah.
They could, but yeah, they won't here. Okay, so you're just going to have a problem like finding that. Okay, the absolute value itself is always positive. If the problem decided to stick a negative in front of the symbol, that's a different thing. All right. Anybody tell me what my formula is going to be before we get the answer? Just square root of, how do we do it?
Root of 3 squared plus 4 squared.
Yeah. And then 3 squared is 9 plus 16. And we get the square root of 25, which is 5. Okay. So that's the absolute value of 3 plus 4i. Okay, and if I think a couple people noticed it, it's a 3, 4, 5 right triangle. Okay. Okay, any question on finding absolute value? What if I had the point negative 3 plus 4i? It'd be the same thing. What if I had negative 3 minus 4i? It's still the same thing. If you have any combination of 3 and 4, the negative is just a different direction we're going. But with absolute value, we're not taking that into account.
So does that mean that 4i is equal to 2?
Well, remember, when we square it, we just took this part and we just took that part. The I is not squared. Okay? This is A,
I get what you're saying.
that's B. All right? So when you're doing absolute value, the I is not part of the formula. Does that make sense? All right, we'll quickly look at addition of complex numbers. We've already done it arithmetically. Now we'll do it geometrically. If you've worked with vectors, this is very similar to adding vectors, okay, which is going to be our next unit, okay, after this week. All right, so suppose you have two complex numbers. Okay, I'm going to call them A plus BI and C plus DI. This one is A plus BI, C plus DI. And what I'm going to do is think of these as being rays. Okay, if I can, I don't know if you can see it's a ray. Let's see. I'll do is just make it again. All right, so bless you. Okay, so I have a ray going to A plus BI. And I'm going to make a ray going to C plus DI. Okay, and so you can see it. Let me make that one green is okay. All right, so to add these up geometrically, all you do is basically take your two vectors. Okay? It doesn't matter the order you do this in, but put one starting from the origin. Okay? Connect the other one, but make sure you connect the end of one to the beginning of the other. And then this is your final answer. So if we had a grid, we could tell how many units to the right and how many units up. Okay? If you switch the order, like let's say you put the green one first and then the red one, it doesn't make a difference. Okay? Because it's commutative. Okay? If we're adding numbers up, you can add them in any order. Right? So let's try that with this one. Right? So this is my first point, 3 plus 5i. My second point I don't like. What do you think I need to do here? Yeah, I'm going to distribute the negative. So really I have 3 plus 5i. That's like my z1. Minus 2 minus I. That's like my z2. Okay, let's represent each one of these as an arrow. So 3 plus 5i. Right 3, up 5. Right, so there's that one.
Green.
Green? Okay. And then the other one is left 2, down. What number is in front of I here?
1.
If it's not written, it's a 1 or negative 1. Left 2, down 1.
Right.
Right, and we're going to make it yellow.
Can't see it.
It's hard to see. Red. All right, so now to add these together visually, okay, I can move them off the grid now because now I have got my two vectors. Okay, I don't need those points. And now I'm just going to start one at the origin. Let's see, I'll do z1 first. That's z1 plus z2, about right there. And that's my answer. Okay, if I started with the other way, let's say I started with, see if I can get this one. Started with that, okay, at the origin, and then did the green one. Okay, I get the same thing. Okay, same thing. So what does it look like my answer is? Okay, so visually we can see right 1, up 4. And then if we had just done it with arithmetic, what's 3 take away 2?
1.
1. And what's 5i minus I? 4i.
A lot easier to graph it.
Yeah, so it's a lot easier, it's quicker to just do it with arithmetic. Okay, but since we talked about a couple things visually, like absolute value and stuff, I'm just kind of tying it into vectors, which is going to be our next unit. So kind of foreshadowing what's coming up. Okay, so any questions on this? All right. So now from this point until we finish our lesson tomorrow, we're going to be talking about complex numbers in trig form. Okay. The whole advantage to trig form is it provides a fast way to multiply, divide, raise to a power, and take a root. That's what we use it for. All right. So I'm going to tie this in with a grid in a minute. So that's why I've switched to using letters X and Y instead of A and B. And if you want to put YI, you can. It's just the final answer that I'm going to come up with in a minute. They have the I first. Okay, but if you want to do YI like we did, that's fine. All right, so when we're writing a number in trig form, we're not going to use X and Y. Okay? X and Y is for standard form. Trig form uses two other things. It uses an angle, and it uses a radius. The angle is the angle with the positive x-axis. The radius is the distance from the origin to your point. Right? And I'm gonna write that down in a little bit. For now, all I want to do is, in this formula, x plus iy, I want to get rid of x, and I want to get rid of y. And I want to rewrite them using r's and thetas. If I took the cosine of theta, what would cosine theta equal?
X over R.
X over r. And if you got x by itself,
That would be R cosine theta equals X.
r cosine theta. Yeah. Okay, so there's a formula for x in terms of r and theta. What would the sine of theta be? Yep, y over r. And if I got y by itself? R sine theta. Okay, that's just using right triangle trig. Okay, we don't need law of sines or cosines because it's a right angle. Any questions on those two boxes? Okay, now we're going to plug in that for x and plug in that for y. And that's basically going to give us the trig form of a complex number. So now instead of x plus iy, now we've got r cosine theta plus I r sine theta. Besides the argument, what do both of these terms have in common? An r. When two terms have something in common, what can you do with it?
You can take it out.
Yep, we can factor it out. And that's how we write the trig form of a complex number. It's r, and then in parentheses, cosine theta plus I sine theta. Again, just as a reminder, what r and theta stand for. Okay, at this point now what we need is we need r and we need theta. Okay, so we need to find the distance that point is from the origin. Okay, it's kind of like finding the absolute value. It's really the same thing. And the other thing we need is the angle with the positive x-axis. Okay, so if we have a point right here, I need to know that angle. Okay, so I need the angle with the positive x-axis and the radius. All right, how do you think we're going to find the radius, if we know x and we know y. Yeah, we're going to use the Pythagorean theorem. Okay? X squared plus y squared equals r squared. Okay? Question? No?
You spell weed wrong.
I spell out which one?
Weed.
Weed. It smells like a weed in the ground.
Use this form, weed. How about weenie? Thank you.
Voice. You need apostrophe D.
Do I need an apostrophe D? Oh, like we need. No, I meant we need. I meant present tense. I spelled it wrong. I think I was thinking we and need and put it all together. All right, so that's the first thing we need to find, that radius. And that's r. Okay, use your Pythagorean theorem. Make a triangle. And you don't need law of sines or cosines because that's a 90. Okay, so x squared plus y squared equals r squared. Now, we're going to go back to that diagram because we still need to figure out theta. Okay, but that's how we get r. Now, theta is right here. How do we get theta using x and y?
Tangent.
Yeah, we're going to use tangent to start out with. And Brad, what would the tangent equal?
Y over X.
Y over x. So now I want to get theta by itself. So what do I do from here? Yeah, take the inverse tangent of each side. So you get theta equals the inverse tangent of y over x. Now that formula works fine as long as you're in quadrants 1 or 4. Okay? Let's see why. When we first started studying inverse tangent, okay, we said if you type in an argument and then press inverse tangent, you're always going to get an answer between negative this number and positive this number. Does anybody remember what inverse tangent is always between? Yeah?
Negative 90 and 90.
It's always between negative 90 and positive 90. So from here to here. What two quadrants does that cover? 1 and 4. So just inverse tangent by itself will always give you an answer in quadrants 1 or 4. Now, when we're working with angles in quadrants 2 and 3, does anybody remember what number seems to come up? Sometimes it's this number minus our reference angle or this number plus our reference angle.
180.
180. Right? So if we want to get an answer in quadrants 2 and 3, it involves a 180 or pi if you're in radians. You have to do inverse tangent, but then add 180 to it. Okay, so 180 plus inverse tangent of y over x. You only have to do this plus 180 at the beginning if you're in the second or third quadrant. If you're in the first or fourth, don't worry about doing it. So now you can see why we may have graphed some points to start out. If you're going to convert a point to trig form, you need to know the quadrant it's in. Okay. Is there any other place an angle could be besides quadrants 1, 2, 3, or 4? It could be right on the axis. Now, let's say we were on the positive y-axis. For any coordinate on the positive y-axis, what's the x value? It's 0. And what would happen if you tried to plug 0 into one of these formulas? It would be undefined, right? If you try to put in 0 for x, your argument is going to be something divided by 0. You can't do that. So when you're on one of the axes, okay, you just have to know that your answer is one of 4 choices. 0, pi over 2, pi, or 3 pi over 2. Okay, which is 0, 90, 180, 270. Okay, being on an axis is actually easier. Okay, if your point is straight up, it's 90. If it's left, it's 180. Down is 270. Also, if you're on an axis, finding the distance to the origin should be extremely simple. If you had the point 5i, and that was it, you really don't need Pythagorean theorem to find the distance to the origin. Okay. What would be the distance to the origin here? Yeah? Yeah, it's just 5. Okay. If you're on an axis, one of your values is 0. Okay. So you don't need Pythagorean theorem. Just count how far away you are on the axis from the origin. Now, if I did something like this, now you have a hypotenuse. You've gone right 10 and up 5. You have to find the hypotenuse. Okay, so any question on how to find r or find theta? All right, so we'll practice changing a coordinate into trig form, and then we'll see how we can use that for multiplying and dividing. All right. What's the name of this form? It's not trig form. It's a standard. Okay. Also known as rectangular. You have a left and a right movement, and then an up and a down movement. So it's grid-based. Okay. We're changing it to trig form. What are the two things that we need to write it in trig form? Two variables. Well, we've got x and y right now. We need r and we need theta. Once we have r and theta, all we're going to do is fill them into this formula and stop. That's it. We don't do anything else. All right, let's make a sketch. Okay, left 2, up 2. Left 2, up 2. Right, make a triangle. Okay, what's going to be my radius in this case? It's going to be the square root of 8. 2 squared is 4. 2 squared is 4. 4 plus 4 is 8. Add them up and take the square root. And that simplifies to 2 square root 2. Okay, so there's your radius. Okay, now my angle. Is this the quadrant where I need to add, one of the quadrants where I need to add 180? Yes. So it's 180 plus inverse tangent of, what's y? 2. And x? Negative 2. Yep. I didn't draw the negative in the picture because that's taken into account by the direction. Okay. 2 over negative 2. So it's really the inverse tangent of negative 1, which is negative 45. 180 plus negative 45 is how much? It's going to be 135. Right? Doing it in degrees, okay, always a good idea. Because if I did this in radians, I would have gotten this number. If I saw the number 2.356, I would not recognize that as anything special. But if I do it in degrees first, and then I change it, I know that 135 is 3 pi over 4. Okay? So if they ask for something in radians and they're giving an exact answer, my suggestion, do it in degrees first, get the nice answer, and then convert it yourself. Don't use your calculator because it's going to give you this, and you'll never get that from that. Okay? Okay. Questions on my radius or angle? All Right, so now my last step, just fill in to the formula. R cosine theta plus I sine theta. Okay, make sure you have parentheses in there as well. So it's R cosine theta plus I sine theta. And that's our answer. Okay, we don't do anything else with that. What do you think would happen if I took the cosine of 135 and then distributed 2 root 2 to it, and then I did plus the sine of 135 and distributed 2 root 2 to it? What answer do you think I would get back?
Standard form.
I would be changing it back to standard form. Okay? So if you take the cosine of 135 and multiply by 2 root 2, you're going to get negative 2. If you do it in the second part, you're going to get positive 2. Right? So don't do it out, just leave it like that. Okay, any question on that? All right, so the formulas that I give you for multiplying and dividing, we're going to go through them in a second, but I want to just remind you of the old way we had to multiply and divide, just so you can see how much faster the new way is. All right, anybody remember what we have to do here to divide complex numbers? We end up changing it to multiplication. And what do we multiply by?
V5 minus I.
Yep. Do you remember what that's called? The conjugate. All right, so the first thing, if you're going to divide in standard form, you have to remember that it's multiplication by the conjugate. Now, this one isn't even that bad because all you have to do in the top is that. If the top was a complex number, then you would be double distributing or FOIL in the top. This time you don't have to. So what do we get in the top? 15 minus 3i. And now the bottom, we'll FOIL it out. 5 times 5? 25. 5 times negative I, 5 times positive I. That cancels. What's a positive times a negative? Negative. I times I? I squared. All right, but now we're still not done. We have to deal with this I squared. What's I squared? Negative 1. Right, so it's 25 minus I squared, or 25 minus negative 1. Okay, so in the top, we've got 15 minus 3i. What's 25 minus negative 1? 26. But now we're still not done. We have to separate it into real part and imaginary part. So 15 over 26 minus 3 over 26. And if either one of these fractions reduced, we'd then have to reduce it. Right? So there's a lot of stuff here, and we didn't even do distributive in the top. Okay? So that's the old way of dividing, okay, in standard form. Any questions on the old way? Okay, with the new way, we're going to avoid having to distribute. We're not going to have to deal with I squareds. We're not going to have to separate into real part and imaginary part. All of that is going to disappear. Right, so suppose we have two numbers in trig form. Okay, I'm going to call my numbers z1 and z2. Each complex number has its own radius, which I'm calling r1 and r2. And each complex number has its own angle, theta 1 and theta 2. The proof of why this is true, it can be a little time consuming, but what ends up happening is you end up with a cosine sum identity, and you end up with a sine sum identity. Okay, so remember those identities we looked at last week? If you were to FOIL z1 times z2 out, this is what ends up happening. Right? two identities you have to recognize: the sine sum, cosine sum, and the sine sum. Okay, but to save time, we're not going to go through that proof. All right, so to multiply two complex numbers together, all you have to do is multiply the radii and add the angles. That's it. Multiply the radii, add the angles. Now, based on that formula, anyone think they can tell me what you would do with the radii to find z1 divided by z2?
Would you just subtract it?
We're going to subtract something, but not the radii. What do you think we'll do with the radii? Okay?
Divide them.
Yeah, divide them. R1 divided by R2. And now, what do you think my angle is going to be? Yeah, it's theta 1 minus theta 2. Right? So to divide two numbers in trig form, divide your radii and subtract your angles. Okay, it is important just to mention that R2 can never be 0. So R2 has to be something other than a point at the origin. Because if your radius is 0, you'd be dividing by 0. Okay, one other thing that can happen here is when you're subtracting, what kind of number can you get when you do subtraction? It usually won't come up with addition. Yeah, we can get negative angles. Well, back when we did, I think it was the sum and difference identity, we talked about what this is the same as and what that is the same as. Does anybody remember what cosine negative x is the same as? What you can do with this negative? You can just get rid of it. Yeah, with cosine, if you end up with a negative for the angle, you can get rid of it on the cosine part. Right? So when you're writing your final answer, I'll show you how that works. Now with sine, you can't get rid of it, but you can move it.
You can move it in front of sine.
You can move it in front. So let me show you a final answer and how we could fix it with these formulas. Okay, let's say you got a radius of 2 and an angle of negative 30. Okay, after you did all the work, you got your radius, you got your angle. So you write 2 cosine negative 30 plus I sine negative 30. Now, most of the time, the directions are going to say write without a negative angle. So, what would happen in this first part with the negative inside the argument for the cosine?
Just get rid of it.
Yeah, we can just get rid of it. So that would just become cosine 30. And what's going to happen with the negative on the sine part? Yeah, we have to put it in front of the factor, so it's minus I sine 30. That's one way to get rid of a negative inside the angle. Or, here's a different way, not using those two identities at all. What can you add to an angle that makes it positive?
180.
If we add 180, that would only bring us halfway around. Yeah, if we add 360 to a point, it brings us right back to the same spot. So that's another way to get rid of a negative angle. Just add 360 to it. So we get cosine, what would my angle be? 330. disadvantage to doing it this way is you've just made your angle huge. Okay? In the second one, you kept your angle pretty small. Right? Both of these are correct. That's why I put or. It just, if the problem says, write your final answer without a negative, do it either way you want. If they say, write it without a negative by adding 360 to the angle, I would want to do it the second way. Okay, so just make sure you read the directions. But I'm going to stick with the second method for the rest of the class. Okay, any questions on that? All right, so let's look at this one together. All right, so I've got Z1 and Z2, and I want to multiply them together, and then I want to divide them. Okay, I've already changed them into trig form for you. In fact, this one, people remember doing this one? We had the 2 root 2 as our radius. Okay, that was example 4. Okay. The only thing is I wrote the angle as 135. Now I've written the angle as 2.36. Okay. That's radians, rounded off. Okay. At this point, I'm not concerned with you writing this as an exact answer, which would be 3 pi over 4. I just want you to understand the concept of how to do this. Right, so let's start with Z1 times Z2. Heaven, what do I do with my 2 radii if I want to find Z1 times Z2? Well, when we want to do Z1 divided by Z2, then we're going to divide our radii. Multiply them together. So what's 5 times 2 root 2? 10 root 2. Okay, so there's my radius. And Tom, what do I do with 0.93 and 2.36 when I'm multiplying? Yeah, we just add them. Say so 0.93 is theta 1. 2.36 is theta 2. Just add them up. 0.93. So my angle is now 3.29, and that's radians. And that's it. Cosine 3.29. I sine 3.29. All right, now let's divide them. Okay, let's do Z1 divided by Z2. Right. What do I do with my radii when I want to divide Z1 by Z2? Divide them. Okay, I'm going to do that down here because look what happens. That's not okay for a final answer. How come? Yeah, so we have to fix that. So what is my radius going to be? So 5 square roots of 2 over 4. Any question on how we got a 4? Root 2 times root 2 is 2 times another 2. So 2 times 2 is 4. Right, so write that down. Okay, and you can write your cosine because you're going to need that. And what do I do with 0.93 and 2.36 this time? Subtract them. Negative 1.43. Okay, so we got a negative angle. 2 ways we can deal with it. We could add, be careful, what could we add to that? 2 pi. Or we can just cancel the negative in one spot and move it in the other, which is how we'll do it here. So what am I going to write here? Cosine. Yep, we can just ignore the negative. And can I ignore the negative when I write the sign? No,
Minus I sine.
but I can move it in front. That's it. Any question on that? All right, so take about 5 minutes and try that one on your own. One of these we've already done part of it. Okay, I want you to take Z1 and Z2. First step, find the radius for Z1. Find the angle for Z1, which you guys already have that in your notes. Okay, next step, find the radius for Z2, which actually comes out nice despite it looking kind of messy. It's a nice number. And then find the angle for Z2. After you write these in trig form, I want you to do what we just did. Multiply them and divide them. All right, so I'll give you a few minutes to try that. If you get stuck, just let me know. So first thing here is to figure out your radius and angle for each point. Okay, for negative 2 plus 2i, we already did that one right here. The radius is 2 root 2, angle 135. Okay, so I won't go through that one again. 2 root 2, angle 135. All right, for Z2, let's, anybody get the radius for that one?
I got 6.
Yeah, it is 6. Let's go through it. Okay, so take your first number and square it. Take your second number and square it, which is minus 3 root 3i. And remember, just the minus 3 root 3. The I is not part of it. Okay, what's 3 squared? 9. Now when you square a product, you square each factor. What's negative 3 squared? What's square root 3 squared? 3. 9 times 3 is 27. And my last step, take the square root. Okay, so my radius is 6. Okay, my angle is going to be, well actually, which quadrant is it in? Right and down. If I'm not asking for a sketch, it doesn't have to be exact. That's just for you to figure out the quadrant. When I ask for a sketch, then I want it on a grid exact. All right, so we're in the fourth quadrant. Do we add 180? No.
Wait, so why do I want to do the other one? Negative 45.
This one we did earlier, Z1. That was an earlier example in the
So
notes.
we're doing this for the first time, or we just leave it negative 45?
This one is in quadrant 2, so no, it's 180 plus inverse tangent of y over x.
It's only positive and then 4.
No, in quadrants 2 and 3, you have to add 180 first.
Yeah, okay.
Right. What's y in this case?
Negative 3 root 3.
Yep, negative 3 root 3 over 3. So just in terms of typing it in, it's easier to cancel out the 3's and do the inverse tangent of negative root 3, okay, which is going to come out to negative 60. Inverse tangent, negative square root 3. Okay, negative 60. Don't worry that it's negative. I don't care that it's negative for this part. All I care about is when we write the final answers. Z1 times Z2 and Z1 divided by Z2, there's no negatives there. All right, so let's write our points. Okay, Z1 is 2 root 2, cosine 135, I sine 135. Okay, what was my radius for Z2? 6 and my angle is negative 60. Again, it's okay to leave the negative because this is not the final answer. Right, so now we multiply. What do I do with my radii? Multiply. So 12 root 2. And what do I do with my angles?
Add.
Yep. And what do you get when you do 135 plus negative 60? 75. Oh, just put it like this. Okay, and that's it. It's Z1 times Z2. Okay, when we divide, what do I do with my radii? Divide them. And when I divide them this time, can I reduce it at all?
Well, 1
Yep.
square root of 2 over 3.
Square root of 2 over 3. Cosine, and now what do I do with my angles? Subtract them, but it's going to be 135 minus minus 60.
No.
195. So you didn't even have to worry about the negative, it just went away by itself. Any question on that one? All right, so now if they asked you to change it to rectangular, the only thing I'd have, and I'm going to round it off, is I would find the cosine of 195 and multiply by root 2 over 3. Okay, so let me show you how that works. Take root 2, divide by 3, and I'm going to store that number. Okay, I'm going to save it as A. Okay, so now I just saved this number. Now I'm going to do A times cosine 195. Okay, and again, this is only if they asked you to change it back to rectangular.
What did I ask? Right?
Negative point, yeah, it's like you're solving it. Negative 0.46. And I'm going to do A times sine 195. A, and that's the imaginary part. Okay, that one's negative 0.12. That's Z1 divided by Z2 in rectangular. Negative 0.46 minus 0.12i. It's just distributing it up, that's all. If they don't ask you to do that, don't worry about doing that. You don't have to. Any question on that? All right, so if your numbers you're going to multiply and divide are already in trig form, this is a pretty nice shortcut. If you have to convert them yourself, I don't know if it really saves that much time. Okay? Where this is really going to save us a lot of time is to try to do something like this. Right? You can't just raise 1 to the 12th and 3i to the 12th. Remember, that's not how it works. You have to write this 12 times and then FOIL every one of them together. Right? Way, way too long. So a problem like this, if we do it in trig form, we're going to be able to do it in about 10 to 12 seconds. To do it out in rectangular form, it's probably going to take you like 10, 15 minutes. And there's going to be so many hundreds of multiplications, you're probably going to make a mistake. So trig form, much better for this. Also much better for taking roots, square roots, cube roots. Right, so those are the two things we'll look at tomorrow. All right, so the homework in the book on 450. Okay, 1 through 3, 5, 8, 10, 11 to 15, 17 to 21, and then 33, 34, 37, 47. Okay, so we'll look at that tomorrow. We'll finish up section 8.4 for tomorrow, and then we'll have our test on Friday.